was this one very famous person scientist, I would say, who actually said that it is much easier to understand the motion of heavenly bodies than the madness of people. It was Newton. So, yeah, I mean, what happened was, I don't know if you guys have studied this in your colleges or not, but there was this one time in 1720s or 1730s when people went crazy for tulips. Yes, I'm talking about tulip, the flower. Does anyone know about the tulip maniac?
Yes, ma'am, I've heard about it.
You've heard about it. So I guess it is kind of a bubble that existed. And what happened was the prices of tulip was rising and rising, rising day by day, month by month. It just kept on rising. So what people did was they thought, if I buy a tulip today at whatever price, and its price is gonna go higher, so I'll sell it the next day and I'll earn some profit in between, right? So this is what their assumption was, and this is what was actually happening. So a lot of people made a lot of money buying and selling tulips. And then, I mean, of course, this wasn't going to continue forever. So someday the bubble got burst, and everyone who holds the tulip on that very last day was at loss of money. And Newton actually lost a lot of money during that period. And that is when he actually quoted this. So, yeah, I would say, even physicists aren't that intellectually talented as economists, at least when it comes to understanding people's madness. But again, I mean, I would say the techniques that we study in economics, so my training has been in mathematical economics. We borrow a lot of stuff from physicists and mathematicians and statisticians, and then we use those to do some logical analysis, as we say, um, to analyze the behavior of humans, which is so much more difficult than analyzing anything in physics, because the laws of nature, they remain constant throughout. So you can again, experiment the same, you can model the same experiment twice, thrice, 100 times in a single room, in a single day, or maybe in a month or something. But when it comes to economics, you cannot observe inflation like in a day. You cannot simulate those things. Maybe now you can, but you cannot have the real life observations of it apart from the time period when it is actually bound to happen. And the thing that we are analyzing in economics is human nature, human behavior, and it changes, it varies, it updates itself from time to time. So it's like the Bayesian thinking, because if you see that something in the past have um, made you incur such and such loss, then you would be mindful of that mistake, right? The next time you try to do that same thing. So the same laws or the same thing that you analyze using the past behavior of that particular human might not hold true for the next time period. And which is what makes humans even more interesting when it comes to analyzing how will they, basically go on with investing their money and all those stuff, because people aren't rational as we know them to be. So there is this emerging field in economics known as agent modeling and DSG modeling and all the sort of stuff, even network theory, so as to analyze the instantaneous changes. And basically what we study, I mean, what you guys must be studying is consumer as a whole, one unit, right? Who behaves equally and same every single time we dictate it to behave like. But in agent modeling, what happens is each and every consumer is considered as one individual, and then you analyze the changes of all of those, and everything affects everything. So it's just much more interesting. Okay, so I should stop right now because I can go on and on about this. Again, I think we have everyone except Lancy, and I don't know why he's not attending lectures, but yeah, I've messaged him. So let me just share my screen. Okay, so for those who have joined right now, what I'll be doing is I'll be playing a clip from my previous lectures for the same question that we tried to do in the last lecture, which apparently didn't get, I mean, it did get a record, but I don't know, the recording is just getting processed even when I saw it today. So allow me to just share my screen. Oh yeah, again, I'm the mandatory. Welcome to the lecture 11 of our CS2 classes. And I'll share my screen. Okay, so do let me know if you guys find anything difficult or anything not clear. So just a minute. Yeah. So do let me know if you cannot hear my sound, okay, from the computer. Can someone say a hi to me just to check if I can hear you guys? Hello.
Hi, ma'am.
Yeah, thank you very much. Okay, so now I'm playing the clip and yeah, just watch it as the actual lecture. Oh yeah, and whenever I say you guys to think, please think for yourself and tell me what you're thinking or message me on WhatsApp, okay? What we looked at was if, let's say, we have inflation. So if we have inflation, what happens is previously the claims were just X, but now they will be KX. And this happens for the insurer company only for the cases where KX is less than M. And here we are assuming that M, which is the retention limit, stays constant and does not change with the change in inflation. So this can vary as well with inflation. So that would be another scenario. And here what we'll have is KX minus M, and for everything where Kx is greater than or equal to M.
Ma'am, Kx minus M or?
Oh, sorry, M.
Only
yeah, M. Yeah, this is for the insurer company, right? So we'll have only M here. And what we generally do is, because we know things about X, we take K from here in denominator there. So we get certain things. And then we try to calculate expectation. So to calculate expectation of Y, what we do is we just take integration from 0 to M upon K. So X value has to be less than M upon K here for Kx times F dx plus M integration M upon K till infinity and F dx. So this is how you go on to calculate the expectation. So let us start off with an example of how do we tackle such kind of questions. If I think there's a good chance of, such kind of a question appearing in the examination. So maybe I'll just put a picture of the question, or maybe I can summarize the question. So what we have is the question says that claims from a portfolio, so claims, which we denote as X, they follow Pareto 6, 1000. So 6 is the alpha, and this guy is lambda. So claims follow Pareto 6, 1000 in year 0. So in today's terms, the claims that are occurring today, as in the year 0, are supposed to follow Pareto with alpha 6 and lambda value 1000. And now we are saying that the scenario that we're looking at is excess of loss, and the retention limit is 500. Okay. And another information which is given to us is that the inflation is at 10% per annum. So inflation is at 10% per annum. Is this clear to everyone? And now the question asks us, what will be the distribution of the insurer's claim in year 1 and year 2 before reinsurance. So what we are trying to do is, we are saying that, okay, we need to find the distribution for the insurer's claims. For what? For year 1 and year 2. So now we know that the distribution is not going to stay the same. As in, the parameters are going to change. The distribution family will stay the same. But this distribution parameters are definitely going to change. Because of what? Because of this added information given to us. So there is inflation in the economy of 10% per year. So if in year 0, the claims follow this distribution, what do you think the distribution would be for the claims in year 1 and year 2, assuming that there is a reinsurance treaty on the basis of excess of loss with the retention limit of 500? So I'll give you guys some time to think about this and try to see what can you do to, arrive for the distribution in year 1 and year 2 for insurer. Does everyone understand the question, or is there anything that is unclear?
Ma'am, before reinsurance is taken means
Huh?
before reinsurance is taken or taking the axis of loss in consideration.
Oh, you don't have to care about that. So what we do is we assume that the insurance treaty is in place.
Okay.
You can ignore that information. So basically what they're trying to say is you need to find the distribution of the claims before reinsurance. Basically just assume that the reinsurance hasn't yet taken place and you try to go on to find the distribution of the claims. So it is eventually going to be the same, right? Even if you take the insurance or you do not take the insurance, but it is just easier to find it when you do not have the insurance in place. So you can just assume that, because the claims will occur at the same rate for both insurance as well as the reinsurance company. So it's okay if you ignore that information, but it certainly helps you if you take that into consideration to, it doesn't matter much if you get what I was trying to say. Is that clear, or do you still have any question regarding that term?
No, ma'am, it is clear.
Okay, thank you very much.
Ma'am, what have you written? Insurers claim payments?
Distribution. Okay,
Okay.
maybe I can. So my question is only to people who weren't present in the previous lecture. What do you guys think should happen now? And we are Mihir and Weber. It's okay if you don't have a clearer idea. Just tell me what's going on in your mind right now. Mihir, Weber, are you guys there?
Yes, ma'am. We
Okay.
have to calculate the distribution for year one and year two, which has its
Yeah.
account. So first we have to consider the CDF of distribution of X for year zero, and then compare it with year one and year two.
Okay, so that is what we did at the end, right? In the previous lecture. Vaibhav, what do you think?
I'm not very sure. I'm still thinking.
Okay, yeah. Don't worry. Keep on thinking. Mihir, can you try in your notebook what you just said and WhatsApp me?
Yes, ma'am.
Hi, Andrea. Did you listen through the whole question?
Yes, ma'am, I could listen the question, but I couldn't listen the part. That's what I mean. I think someone explained something. I couldn't do that.
Oh no, no one actually explained anything. We
Oh,
haven't
okay.
yet started the solution. So yeah, we want you to put on your thinking cap and guess what you should be doing.
Yes, ma'am. I am thinking.
Yeah, very good. And about the rest of you, I think you all can work on the second part of the question. So Isha, Savri, and Manshita, try the second part and tell me what do you guys think and the way you should be approaching that second question. If you want to discuss, use the WhatsApp group. It's free for everyone.
Ma'am, for the second part, we have to consider the reinsurance part also, na?
Yes. Because and then only you will realize, the paragraph that we had a look at in the theory part. It only happens if you have it.
Ma'am?
Okay, did anyone from this class just called me or was it the recording?
Yes, ma'am, it was me.
Okay, yeah, go on.
So they're saying that find the percentage increase. Ma'am, there's a lot of echo. I can hear myself again.
Is it better now?
Yeah, this is better. Oh no, it's coming again.
Mm.
Can you stop presenting for a couple of minutes?
So it's actually not playing anything.
But I think it's because of that itself, because you must have kept the computer audio on.
Oh, yes, I've stopped my computer audio. Is it better now?
Hello? Yeah,
Hello?
this is better.
Yeah.
So I was saying that they want the percentage increase in the insurer's mean net claim payouts in each year. So do we have to like find out like basically I found out the expectations first, and then do we have to find out like the increase from year one of year one from year zero, and then year two from year one, or year two from year zero itself?
Year 2 from year 1.
Okay.
So first of all, you will have to figure out the mean payment for year 0, then for 1 and 2. And then you just have to figure out the percentage difference.
Yes, ma'am, done. Should I send it to you on WhatsApp?
Yeah, yeah. Okay, so Isha, are you there?
Yes, ma'am.
Yeah, so what you have done is actually, if we don't take reinsurance into account, so the thing that we did in the first part, we had an assumption that we are not taking reinsurance into account. But now in the second part, you have to take into account the reinsurance. So Y1 will not necessarily be the distribution that we claim it to be.
Okay, got it.
So I said that in this lecture, I would say, but again, I did correct that later on. So yeah, the distribution changes. Vaibhav, are you there? Vaibhav?
Yeah, yes, ma'am.
Yeah, so what you have sent me is correct. There is just a bit of, I guess, error. The last step where you write, 1 minus 1000 upon 1100 plus x raised to 6, it should be 1100 in the numerator as well, right? When you take 1.1 from the denominator to the numerator and then...
Right. Yes, ma'am. Got it.
Yeah. Okay. So, yeah, only that part. And where? Hello. So whoever has finished the part 1 of the question, now you can move on to the part 2 of the question. And I guess the question is in the WhatsApp group. Until then, I'll go to my usual lecture taking class. Okay. So excuse me for a while and I'll join you guys back soon. You guys be in the meeting. I'll make Anvaya the host for now at least. Yeah. Oh no, her internet is not stable as well. Isha, I'm making you the host, okay? Oh, Anvaya, now you'll have to make Isha the host. I lost my powers. Yeah, anyways, you guys manage, okay? So I'll be back in a while.
Bye now.
यार सेटअप कितना का हमारा बच गया आपके
Mihir, am I audible?
Yes, ma'am.
Yeah, so Mihir, what you have sent me, I mean, it starts very correctly, but at the end, when you have to, solve for the x times in whatever is in the bracket, you're using the rule of differentiation, right? Not the integration.
No, ma'am, integration only.
So did you use the fact that, the limits do not depend on x, and that is why you used it?
Ma'am, I didn't get you.
Hello, am I audible?
Yes, ma'am.
Okay, yeah. Savri, where should I start from?
Sorry, actually, I first calculated for year two. So,
Oh, okay, okay. Okay, fine. No
sorry,
worries. Yeah, it's fine.
Ma'am, I'm stuck with the expectation.
Okay, can you send me whatever you have tried?
I'm like I just know how to do the CDF part. That is the second part, but first part I'm not even getting how to start with it.
Okay, so let me just write it on the board. I see what Savri has done, and your year two's answer is not exactly what I have, but yeah, it's fairly close. But again, I'll have to go through your next steps. And I'm sure it's just a matter of some decimals. Let me check your another answer. Yeah. Yeah, so Sauri, your answers for year 1 and year 2, right? You have only figured out those as of now.
Yes, ma'am.
Yeah, both of them are correct.
Okay. So I should calculate for year 0 also, or for increase it's okay if you just calculate for year 1 and year 2?
No, so you'll have to figure out year 0 as well. And again,
Okay.
you know, so because in the question they have mentioned it for each year. So yeah, you can do that. So again, you know, whenever we have such kind of questions, what you can do is instead of substituting the numbers of lambda and alpha, just walk through them. And then at the end, you substitute those, right? Because you get a generalized formula. And then it's easier for you to just substitute in alpha and lambda values instead of deriving it every year, right? And the increase, the percentage increase, that's the formula that we have used. Just check it once, because if you have to figure out the percentage increase, this is not the formula you use.
Okay, ma'am. Thank you.
Yeah. So, Mihir, your integration part is a bit, I would say, not correct. And again, let me just write it on the board right now. So, Vaibhav, did you try? Vanshika, what about you?
Ma'am, I'm on year 0, but I'm stuck on the integration only.
You're stuck on the integration only? Okay, so we'll go through it together. Let's see. So we have to figure out the percentage increase in insurers mean net claims payment. Okay. So the very first equation that we have will be of, you know, the way we write the expectation basically. So we know that the amount will be X. So if I'm doing it for year 0, let us say I'm doing it for year 0 first. So if I were to write my expectation of Y0, what I will have is integration from 0 till 500, and the value will be X, and the PDF is something like this. And then again, I have integration from 500 till infinity. This is my M right here. And again, I have this thing. So I hope that everyone can solve this part at least. Does anyone have any problem with B part?
No, ma'am, that can be solved.
Okay, so let us just focus on the A part right now. So what we will try to do is, we'll take all the constants outside and we'll leave ourselves with only this x's inside. So there are again many different ways in which you can solve this particular integral, but I'm just going to use this method right now to illustrate. So what I'm going to do is I'm going to take this outside because it does not depend on x, and I'll have integration from 0 till 500 x times x plus lambda raised to alpha plus 1 dx. Does anyone have any idea of what I can do next? Savri, can you guide us through your method? What did you do next?
Yes, ma'am. Ma'am, actually there it will be minus alpha minus 1, right? In the formula.
Yeah, thank you very much. Yeah.
Ma'am, I substituted lambda plus x as t.
Yeah.
And then I calculated the values for u, like for limits.
So for limits, we need to figure out, right? So for x equals to 0, My mu is lambda, and for my x equal to 500, my mu is 500 plus lambda, right? And instead of x, what will you write now? Mu minus lambda. And instead of x plus lambda, you will just have mu. So I can maybe, again put it in the denominator, and I'll just add mu raised to alpha plus 1 dx. And now can you guys solve it? Do you guys know how to solve this integral now? Hello. Vaibhav and Isha, can you guys hear me? Vanshita?
Yes, ma'am. I'm just trying to do it by myself.
Okay, yeah, good. Just reply to me, okay? Because I can't really see you guys, so it's difficult for me to even know what you guys are doing. I mean, did you guys listen to me, or was there some technological error or something? So yeah,
Ma'am,
just be there. Yeah.
what happened to x plus lambda? Oh, we took it as mu.
Yeah.
Okay, so we took it as mu and then we put it in the denominator again.
Yes. I mean, you do what you are most comfortable with. And Mihir, so what do you think the mistake is in the answer that you sent to me? Do you realize it?
Yes, ma'am.
So what was it?
Ma'am, I didn't change the integration.
Right. So, and again, like the formula that you have used is, I guess, by parts. Is it by parts?
Yes, ma'am.
Okay, yeah. Vanshita, are you there?
Yes, I am there.
Are you solving this integral?
Yes, yes. I'm trying to.
Okay. Yeah. Isha?
Yes, ma'am, solving it.
Actually, while I was solving by myself, it was the reinsurance part, right? So I thought I don't know, it just clicked that reinsurance, so it should be from the reinsurance point of view. So I was taking X minus 500.
Okay. That's good. That's good. No worries. It's just a bit more practice for you. That's good, anyways, I would say. Do share your solution with us. We'll have a look.
No, I didn't reach further. I was thinking from since when, and I just got this idea, and I was going forward, and then I saw the screen.
Okay. No worries. So again, don't think of much complicated stuff. This integral is really easy and really straightforward. Only if you can see through it.
Ma'am, after integrating, should we substitute mu as x plus lambda again and then put in the values?
Yes, because at the end you have x, right? So yeah, you should do that substitution again.
Okay.
Can you send me a picture of what you have done up until now? So that I can
Yes,
check.
ma'am.
Yeah. So Vaibhav and Vanshika, Mihir, are you solving?
Yes, ma'am.
Good. Yeah, that's the way to do it, Isha.
Yeah, okay, ma'am.
So Vanshika and Vaibhav, Savri, you are done, right? Let me give you another question to solve till then. Are you there?
Yes, ma'am.
Okay, so this question may be a bit weird, but yeah. I'm just giving it as an extra question. So I'm writing the question here. So, okay, again, my X are claims which follow Pareto with parameters 3 and 500. Okay, and the reinsurer, it wishes to draft an excess of loss treaty. So we have an excess of loss treaty, but again, there is a condition. So the insurer thinks that 50% of the losses should result in no claim for the reinsurer. So let me just write the whole sentence here because that is what is important. So we have an excess of loss treaty such that 50% of the losses result in no claim. So what you have to do is calculate M. So again, another name for M, which is actually in the actual question, is the size of deductible. So why is it known as deductible? Because that is what you deduct from X, right? X minus M. This much is paid by the ceding company and the remaining part of it is paid by the insurer company. So that is why this M is also known as deductible. And yeah, this is the question for you, Savri. If you can take a screenshot and let me know, I'll change my screen to the question that the rest of them are on.
Ma'am, you can change. I've written it down.
Oh, perfect. Yeah, so Vaibhav and Vanshita. Again, I think Isha, maybe you can do that question a bit later, and Mihir, if you have understood your mistake and you can send me the working of your question right now, forget about the calculations of expectations and everything. You can also move on to the next question and send me the rest part of this. Oh, Savri, you also have to figure out the percentages, right? So the formula that you used was not exactly correct. So I want you to recalculate those percentage increases and then move on to the next question.
Okay, ma'am.
Yeah. Vanshita? What are you thinking? Again, I don't know if I should say this or not, but let me just have a poll. Okay, let me see how do I conduct a poll on. It's too complicated. So, do you guys prefer online exams or offline exams?
Offline.
What about others? Because I think that there is a good chance that your exams might be offline. I mean, most of my cousins, my friends, and my brother, even they have to go and take exams offline to their colleges. But again, we can never be sure of the second wave coming in or even more stricter restrictions
Ma'am,
being
but
imposed.
IFOI has already announced, right, that the April exam will
Yeah.
be online.
So IFOA has announced it will be online. For
Is there
II,
any chance that they might change it to offline?
oh, I don't think so. So IFOA, I think for them it's better to have it online because I mean they have a varied presence. So if they are conducting offline exam at some place and online at some other, I don't know how it's gonna function. But I think for them, if they have everything in place, then online is just better.
Ma'am, but it's really difficult to type in everything
I
and
know,
all.
I know. It's like it's more of a test of your typing as well. I know I'm really bad at typing. I make so many errors. So yeah, I
And ma'am,
think
at least like if we have lesser time, we can just like hurry up by writing faster,
yeah,
but while typing, you can't really do anything.
yeah. I agree. I agree. I think even to type an integral, it's gonna take a bit of a time.
I'm basically like I had given the CS1 exam right now, so they don't basically they don't expect us to write the integral in the same way. But I think that's even worse because we are so much used to seeing integrals in a particular way, and then we can't really think ahead what to do, right?
Yeah. I don't know. I think they should have allowed, to write in papers, then scan and then just upload it. I mean, that is how my exams happened, my final exams for my masters. So, don't know.
And
But
they
yeah,
might have trust issues.
trust issues. We shouldn't even start talking about that. Seven 7.7. Okay. Yeah. So, Savri, what you have written now makes sense. Savri, can you hear me?
Yes, ma'am.
Yeah. So now it makes sense. But again, the actual answer for year two is, I mean, what I have is actually 199, and what you got is 201. So that's a bit of a difference, I would say. So just check up your numbers, I would say, once.
Okay, ma'am.
There's a difference of 2. But again, do that later on. Now you move on to the next question. This error checking thing is weird.
Excuse me, ma'am.
Yes, Vaibhav?
Ma'am, in here one and here two, the only difference will be in the change of the lambda parameter, right?
Yes.
Okay. The rest of the integration is all the same, right?
Exactly. So that is why, it always helps you to do the first bit without substituting alpha and lambda so that you can save your time of deriving it again and again for 3 times.
I'm a little out of touch with biparts integration. That's why I'm struggling a little.
Uh, so you don't actually have to use bypass. Think beyond that. Try to make your life simple, Vaibhav. Did anyone calculate the year zero expectation?
And I got 174.96.
Yeah, I mean that's about it, I would say. Can you send me your calculation?
Yes, ma'am.
I mean, the answer I have sent you, I haven't added the second term. So in the solving part, of course.
Okay, yeah. Then it's fine. Then it's fine. If you add it, then yeah, but the approach is correct and everything else is correct. I'm not checking the calculations. I trust you guys with plus, minuses, multiplication, and division at least.
Okay, ma'am.
Ma'am, my sum just went haywire after I substituted x plus lambda for t.
Isha, why? You just sent me the picture, right?
I did, but that was before substituting it, right? So right now when I substituted it, so basically I got like a really big value. Should I just send it to you again?
Yes, do send. You shouldn't be scared of big numbers, okay?
No, I wasn't, but then I got like I substituted the numbers and I'm getting a negative value now. So
Okay, that's a worry. Send me. Vaibhav, how far you are? How far did you get? Okay, I'm checking your answer, Isha. So Isha, what you can do is when you're substituting instead of tx plus lambda, you don't have to do that right up there. You first have to substitute the upper and lower limits and then you resubstitute those values, right? Because this lambda and 500 plus lambda still represent the values taken by your t.
oh right, the limits will change again.
Yeah. So first substitute in the limits and then solve for x by substituting for the t. So guys, I would say it's actually possible to get the precise answer. And because Mihir has gotten that answer to like 3 decimal places correctly. So I would again urge you all to be mindful of your numbers.
Ma'am, can you show the next sum?
Oh, yeah. This. Yeah, Vaibhav, yes. Thank you very much. Yes, that will be due. Can you? Oh, yeah. Oh, wait. I have paused my screen sharing. Yeah. Vision, can you see the question now?
Yes, ma'am.
Yeah, and I'll correct that. Thank you very much, Vaibhav. Savri, are you doing this question?
Oh, yes, ma'am, I'm fine that.
Okay. Isha, what about you? What are you doing right now?
Ma'am, I'll just solve that part one so that even if I get the right answer for the first year, I'll just move ahead to the next sum.
Okay. Yeah. Vaibhav, are you there?
Yes, ma'am, I'm here.
Yeah. So, were you able to see through the integral? I know it can
No.
be very difficult sometimes to even see the obvious. Okay, so let me reveal it to you. There you go. And I guess next is just substitute and yeah, whatever.
Ma'am, can you go back just for a second?
I think I lost everything I did. Yeah, yeah. Yeah. Mihir, that's exactly how you have to start. Good going. So now you just have to figure out the value, right? For
Yeah,
M.
just a value of
Yeah. Figure it out. So I'll till then write the percentage increase on the board. Vaibhav?
Ma'am,
Yeah.
is the answer for the year 0
Hmm.
129.77?
That is, I guess, for the first part, right? Not the whole of
Yeah.
it?
Just a second, I'll calculate it and let you know.
Yeah.
Ma'am, so is it 147.4? Ma'am?
Oh, sorry, I was muted. Yes, Isha, you were saying something?
Yeah, ma'am, is the answer for year 0 147.4?
Not. It is actually 173.66.
Okay, so was the answer for the first part correct?
Yeah, it was correct.
Okay.
Vaibhav, are you able to solve?
Yes, ma'am, got 173.67.
So what was the mistake you made?
So in the f of x formula, in the denominator, instead of lambda plus x, I was taking lambda plus alpha.
Okay, good. No worries.
Can you show the next question?
Yes. There you go. Vaibhav, can you hear me?
Yes, ma'am, I got the sum.
Okay, you got it? Right. So are you also trying the next sum now?
Yes, ma'am, I'm just starting.
Okay, perfect.
Can you please explain this question?
I will. But first I want you to, not give up so easily. Try to understand. Read it twice, thrice. This is actually a question from exam.
Or can you read out the whole actual question once?
Okay, so yeah, it is actually similar. So X follows Pareto with parameters 3 and 500, and the reinsurer wishes to draft an excess of loss treaty such that 50% of the losses result in no claim on the reinsurer. So basically, okay, I'm not explaining it. I'm trying really hard to, keep myself from exposing the essence of the question. But again, this is like those word problems. Just think about it, read it again and again, and try to write it in terms of math, word by word, and maybe phrases by phrases, I would say. So maybe I can give you guys a bit of a hint. I don't know how much it will count, but yeah. That's my hint. Yeah, sorry, I'll look at your answer in a bit. Mihir, I'm looking at your answer right now. Wow, so both of you got the same answer and it's incorrect. Let me break it to you guys now. And I'll tell you what mistake you guys did. Yeah. So again, what f of x did you guys use? Both of you guys. So I'm talking to Mihir and Savri right now.
Pareto distribution.
Is that really the distribution for reinsurance company? So we did see, a separate conditional distribution for reinsurance company, right? You're supposed to calculate that, then figure out the distribution, and then calculate the expectation.
Okay, I've got it.
Yeah. So try to do that. And till then, Isha and Vaibhav, again. Isha, did you understand the question?
No, ma'am.
No. Vaibhav, you did, right? Can you explain it to Isha?
So from what I gather is basically 50% of the losses do not result in reinsurance. So that basically means that 50% of the losses are less than that M amount, the amount after which the reinsurance company pays. So we'll take the CDF and then we'll equate that to 0.5 and through that we'll find the value of X, and that's as far as I've reached now.
Isha, did you get what he explained?
I understood what he said in the first part, but I didn't understand the CDF part.
Okay, so let's, again, take out all the ingredients from the question one by one. So first, we know that the claims follow Pareto 3,500, right? Why is my cursor stuck? Okay. So it follows 3,500 Pareto X. Fine. And now what we're having a condition for insurance company is that they do not want more than 50% of the losses. Sorry, wait. Yeah. So they do not want 50% of the losses to result in any claim for them. So what the question says is that the 50% of losses should result in no claim for the reinsurer. So it means both, that is the 50% result in claim or 50% do not result in any claim for the reinsurer company, right? So again, what does it mean when it is saying that 50% of the losses? So whenever we are talking about losses, what exactly is loss representing here? How do we represent loss in this question, Nisha? What is loss for me as a reinsurance company?
Whatever claim amount I have to pay, right?
Right? It is the claim amount which is denoted by X, right? So now I am saying that 50% of my losses. So if you convert it in terms of what we know, 50% of the total claim amounts, right? So what we are saying is that 50% of the total claim amounts should not reach the reinsurer, because they are saying that 50% of the losses result in no claims for the reinsurer. So when I'm saying no claim For reinsurer, what will be the condition in which there will be no claim for the reinsurance?
When those claims are below the retention limit.
Right? So when those claims are below the retention limit. So now if you try to have a look, what exactly are they trying to ask you? Can you guess the equation now?
Oh, so they are asking us to find out the probability where x less than m equal to 0.5.
Exactly. And now you know the distribution of x, and you can just substitute in m as a constant and then solve for m. Vaibhav, did you solve?
I got the value of x as 129.96, but I'm not sure if that's right.
The answer is correct, but is that really the value for x?
No, I have to substitute and find the value of m, but 129.96 is the value I've got for x.
What? Why do you have to figure out the value of x? We only have to calculate the value of m, right? The retention limit. Can you send me your working?
Ma'am, for the second part, do we have to again show all the workings, or we can directly use the formulas that we have derived earlier?
You can directly use the formula. You don't have to show the working.
Got the answer, ma'am. 129.96.
Got it? Very good. So now let me show you guys the second question. So yeah, this is the second part. Try to solve this now.
Ma'am, can I leave the lecture right now? I have an assignment to submit and a test tomorrow. So I'll try
Oh
out
yeah,
this
it's 8:35. So yeah, don't worry about solving this right now. You guys can solve it later as well. And yeah, I guess let us end today's lecture with this, and we'll have the next class on Wednesday. Does that seem good? And all the very best to anyone, who is having other stuff apart from this, if it's tests, assignments, anything.
Yes,
Yeah,
ma'am. Thank
but
you.
do keep actuaries in mind as well. So yeah, and if you guys have any doubts, do let me know in the WhatsApp group, or you can put it on the Google Classroom if you feel. But yeah, WhatsApp is convenient, right? So I'm just hoping that today's recording does not get messed up. With that hope, I'm gonna stop screen share and stop the recording as well.